Let's solve a problem involving a gravitational force. Equation that allows one to calculate the mutual force of attraction that one object has for another is shown here. It's the universal gravitational constant times the product of the masses divided by the square of the distance between them. I have at three of the vertices of a rectangle objects. Lower left vertex is a 2 kilogram object, lower right vertex 3 kilogram, and upper right vertex 5 kilograms. The width of the rectangle is 4 meters. The height of the rectangle is 3 meters. The length of the diagonal is the hypotenuse of this 3, 4, 5 triangle. Hypotenuse length 5 meters. Our goal is to find the sum of the A and B vectors. We'll call the sum of those two vectors F, which will stand for the total force on the 2 kilogram object. So the force vector is A vector plus B vector. The A vector points from 2 to 3. The 3 is pulling on the 2 kilogram to our right. The 5 kilogram object is pulling on the 2 kilogram object with a force vector that lies along the diagonal. The problem becomes quite similar to any problem we've solved before involving the sum of consecutive displacements or the sum of 2 or more displacement vectors. Here it's the sum of 2 force vectors. Procedures are the same. We will need to know the x and y components of the A vector and the B vector in order to find the x and y components of the total force vector. To find the x and y components, we need to know the lengths of the A and B vectors. Lengths being in force units, newtons. I show here the force vector labeled A. Following the g/m over r squared pattern, we have the universal gravitational constant, 6.67 10 to the negative 11, times the product of the masses, 2 and 3, divided by the distance squared. This works out to 2.5 10 to the negative 11. Now let's do the B magnitude, the length of the B vector. 6.67 times 10 to the negative 11 times the product of the masses, 2 times 5. All divided by the square of the distance between the 2 and the 5. That distance is 5 meters. That works out to 2.67 times 10 to the negative 11 newtons. Now we can calculate F sub x and F sub y. F sub x is the sum of the 2x components. Before we can find the x component of both vectors, we will need to know that angle. I'll show what that angle is here. It's the angle whose tangent is 3 over 4. That's theta. This is 36 0.87 degrees. Now let's go back to f subscript x. It's equal to ax plus bx. Well, the x component of a is 100% of the value or length of the a vector, because the a vector lies 100% along the positive x-axis. So a sub x is just whatever a is, which is 2.50. And I'll leave off the factor of 10 to the negative 11 because all of the future components and final force value that we'll calculate will be in terms of 10 to the negative 11 newtons. And so to save writing time, I will leave off the 10 to the negative 11 to speed things along, and then restore it or put it back at the very end. And b sub x is required next. B sub x is the value of b times the cosine of 36.87. b is 2.67, remember, leave that off, times the cosine of 36.87 degrees. That works out to 4.63. And I'll leave the units off as well as the factor of 10 to the negative 11. Now let's find f sub y. It's a sub y plus b sub y. What about a sub y? Well, a vector lies 100% along the x-axis, so no part of it could cast a shadow along the y-axis. The y component of a is 0. And then we have the y component of b. The y component of b is the length of the b vector times the sine of theta. That would give this component. So it's b times the sine of theta, but b, remember, is 2.67. And here's your sine term. And I'll calculate that for you now. I get 1.60. Well, these are each in units of 10 to the negative 11, or multiples of 10 to the negative 11 newtons. The value we're looking for is the length or magnitude of the f vector. And so let me calculate that for you. All right, here we have the final result, the length of the force vector F, which is the sum of the two vectors A and B, the sum of the forces acting on the 2 kilogram object. Square root of the sum of the squares of the components. F sub x component, F sub y component, square each one, add them, take the square root of that sum. The final result is 4.90, but don't forget we need to restore the factor of 10 to the negative 11 that we remove to make our writing smoother and simpler and shorter. Final result then, that's the force, a very small one indeed, acting on the 2 kilogram object. That concludes this lecture.